Imagine a world where your business workflows are no longer bound by lines of code. Picture this: you describe a process in plain English. When a customer purchases a product, verify inventory levels, then initiate shipping. And an AI transforms that into a self-executing smart contract on the blockchain. This isn't science fiction. Researchers are actively testing whether large language models like GPT or Claude can bridge this gap, turning human language into reliable, secure code. But here's the critical question: can these AI systems deliver consistent, error-free results? Smart contracts aren't just automation tools. They're the backbone of decentralized systems, enforcing agreements without intermediaries. Their power lies in precision. A single misplaced semicolon or overlooked edge case could trigger catastrophic failures, wiping out millions in assets. So how do you even evaluate if an AI can translate a business process into a functional smart contract? Enter a groundbreaking study that's redefining the field. Researchers didn't just ask AI to write code. They developed a benchmarking framework, a rigorous testing protocol, to assess how well language models convert workflow diagrams into working smart contracts. They fed the AI 165 detailed process diagrams, each representing a step-by-step blueprint for operations, from order fulfillment to supply chain management. Then they didn't just check if the code compiled. They tested whether it enforced rules correctly, handled exceptions, and maintained security under real-world conditions. Here's how they did it. The AI received a handful of example workflows through few-shot prompting, letting it learn patterns before tackling new tasks. Then an automated system simulated scenarios like order cancellations, inventory shortages, or timing mismatches. Essentially, the AI's recipe was put to the test with unexpected variables. It's like giving a chef a recipe, and then introducing a burnt ingredient or a missing spice to see if they adapt. The results: some models like Claude Sonnet and Grok 3 achieved accuracy scores above 0.8, outperforming others. But here's the caveat: even these top performers had a 20% error rate. Think of it as a chef burning 1 in 5 cakes, unacceptable in a high-stakes environment. The unpredictability of LLMs means they might overlook critical conditions, misplace steps, or introduce vulnerabilities. In blockchain, where contracts are immutable, these errors can't be undone. Yet this study isn't just about limitations, it's a milestone. The researchers open-sourced their framework, creating a shared lab for developers to refine AI tools. This is a foundational step toward democratizing blockchain development, but the takeaway is clear: human oversight remains non-negotiable. AI isn't a replacement for expertise. It's a tool that requires careful validation. So what's next? We're glimpsing a future where AI acts as a co-pilot for developers, suggesting code optimizations or flagging risks while humans handle final decisions. Or imagine a world where non-technical users design workflows through natural language, bypassing traditional coding entirely. But for now, this tech is in its infancy, full of promise but far from production-ready. Ready to see how this plays out in practice? We'll break down the experiments, dissect the error patterns, and explore what these findings mean for the future of AI-driven blockchain. Stay tuned.